All right, well, here we are. This is the final of our lectures. We have covered a great deal of ground so far, including some very basic bivariate tests and some multivariate tests, including correlation analysis, ordinary least squares regression analysis, and we've started talking about logistic regression. So today we're going to spend some time focusing on how to interpret a logistic regression model. Okay, just as a reminder, logistic regression is only used if your dependent variable is a simple dichotomous or binary variable. That is, it only has two values, 0 and 1. Maybe some of you have a variable that says 1 and 2. That still means you only have two values on that variable. So if that's the case, you can use logistic regression to estimate what is the relationship between your independent variables and your dependent variables. Now, as I mentioned before, it is a very different type of multivariate test. It's different from OLS regression in a couple ways. In part because it has to translate all of our independent variables into probabilities. So it's trying to predict the likelihood of something occurring. It uses maximum likelihood estimation to do that. So that alone means that the interpretation of this model is not as intuitive as it is for OLS regression. There are some similarities, but then there are some fairly big differences. So to interpret logistic regression coefficients, you must specify a value for each variable and use the resulting coefficients to predict the probability of y, or your dependent variable, occurring. The coefficients, therefore, do not on their own indicate the magnitude of the relationship between an independent and dependent variable, just the direction of the relationship. In fact, in addition to the direction of the relationship, obviously you'll find out that the relationship is significant or not significant. So let's go through this real quickly so that you understand what this would look like. This is very similar to what we did in OLS regression, which is getting some margins. That's going to tell us what's going on here. So let me highlight a couple things. Let me see if I can get this pen going here. Okay, this is a sample logistic regression output from Stata. Here is our command. It's going to give us the number of observations, in this case 792. It's also going to give us this weird thing right here, the pseudo R squared. Some of you are probably going, wait, what is that? Turns out this is not super useful. It just gives you an analog, something that you can compare to a regression model, and you would interpret it like you would interpret the R squared in a regression model. But it's really kind of a wonky little number, so we don't usually report this as a goodness of fit measure. Okay, we'll talk about that in just a second. You'll notice that this model, because it's a maximum likelihood estimator, it actually runs many models before it can converge on a set of estimates. This number right here, the log likelihood, is one of the pieces of information we usually put in our final table. We usually like this number to get closer to 0 if possible. Realistically, we rarely ever see something that small. This is a useful number only insofar as we can compare this to a log likelihood of another logistic regression model, maybe one that includes more or fewer variables. Okay, so it's just in relation to another model. We don't worry about interpreting it. So I'll show you goodness and fit measure just a second. But this looks just like an OLS regression in the sense that this is your dependent variable. Here are your independent variables and your constant term. Each column, this first column here, giving you coefficients, standard errors. We're going to ignore that third column. And this is your p-value, which indicates whether or not you have statistical significance. So let's say, for instance, for this incumbent variable, we've got some sort of coefficient which we can't interpret, and we see that it is very statistically significant, right? Pretty good, right? Okay, but let's go back a sec. Let's go back a sec and let's find out whether or not this model is performing well. So how do we do that? We need to get a goodness of fit measure, and because the first thing that Stata gives us doesn't really give us a good goodness of fit measure, we ask for the ESTAT classification addition. So let's say we just ran a logit model, and right after we run it, we're going to ask for this. What this does is it gives us a rate of prediction. It tells us whether or not we have correctly predicted the outcome on that dependent variable, right? So we have 792 observations. We are going to look down here at this number. How many of our observations are correctly classified? It's looking at an expectation for classification and then the observation. So how many times do we correctly predict that the outcome will happen? In this case, the model has correctly predicted 91.92% of the time. It's correctly predicted the outcome. Generally speaking, as long as you're doing better than a coin toss, what is the probability of correctly predicting a coin toss? It's about 50%, right? So as long as we do better than a coin toss, then this is our measure of goodness of fit. So in this case, I'm feeling pretty good about this model because I'm doing a pretty good job of predicting. All right, that's step one. We can talk about the goodness of fit, how well the model is performing. The next step is what's going on with my coefficients. Aside from sign and significance, these coefficients that are produced in Stata are not intuitive. So in your write-up, note that first, and then note that I mean note sign and significance, and then run the margins. So as far as sign goes, these are read just like OLS regression outputs. If there's a negative in front of that coefficient, there's a negative relationship between that variable and the dependent variable. Same if it's positive, is a positive relationship between those two. Significance, we just looked at that in the table. We can easily see if the p-value is 0.05 or less, then it's statistically significant. All right, so beyond that, we want to know something about how these variables are performing with that dependent variable. So we're going to run a margins command. You've already done this for OLS, hopefully, right? And it's going to look very similar to that OLS margins command. We are not going to calculate the margins in logistic regression because it's a little bit messier. It's actually a lot messier. So we're just going to go straight to the margins. And what this tells us is we're going to keep all the variables at their mean, and we're going to allow incumbency to vary because I know that it goes from 0 to 1. Actually, it goes from 0 to 2. So it actually ignored me, as you can see. It goes up to 2. And I'm going to ask it to give me margins. So we're going to cross this out. That should read 2. So as you can see here, we're going to see some margins. So when incumbency is at, let's say, 1, the likelihood of something occurring, the likelihood of, in this case, I believe it's Democratic vote share, I coded it, Democratic vote share exceeding 55%. So a strong win, right? So when incumbency is coded as 1, a low value, the probability of that vote share being above 55% is 29.44%. When incumbency is coded as 2, oh my goodness, look at that. The probability of that outcome occurring, a strong win, is 91%. That's quite amazing. All right, so those are the margins. Let's go a step further and let's make a little plot, okay? In this case, we've got incumbency right here on this axis, and this right here tells me that my prediction when incumbency is at 0, and in this case, it's just telling me up to 1. So when incumbency goes to 1, we expect that. And it's going to give me the probability or the likelihood of new DVS. So the likelihood of a strong win, right? The likelihood of something occurring in that dependent variable, in this case, is down here somewhere around 30%. 0.3. And when its incumbency is at 1, it goes to right about here, which is about 90%. So when it's going to that particular higher value, okay? So it's telling me the same thing that I saw in the previous margins. The numbers here are a little messed up, but you get the idea, right? 29%, roughly 30% to 90%. That is a pretty big impact, right? And at either end right here, as you can see this little part right here, that's my confidence interval. So my confidence interval around this higher prediction is pretty small, which means that I would expect the true population parameter to be somewhere inside here. And I would expect the true population parameter to be somewhere inside here. In other words, I'm pretty confident about this finding. I'm also pretty confident about this one. And I can tell you that incumbency has an extraordinarily positive impact in terms of making these kinds of races particularly strong. Okay, so the last part of this I'm going to remind you is to put all this information in a table that looks kind of like this. Now, this table is not related to the results that we just had, but it is, of course, to highlight what we have talked about in respect to proper display of multivariate regression results. Table title, you've got model, you've got independent variables located here. See, there, there, there. You're going to list the constant, you're going to list the n size, and, oh sorry, we're going to erase the 2 in there. We're going to add the log likelihood. Underneath this table, or even in here, you can add classification. Sorry, my handwriting is awful on this. Okay, if you remember, it was something like, is it 91% or 92%? We would put that in there if you want. If not, you can leave that in the context of writing up the results. Okay, that's optional. All right, so far so good? I hope so. So in short, Logit is like OLS, but it's different. Like OLS, you are going to be reporting on goodness of fit. You're going to be reporting on whether or not your beta coefficients are significant and what kind of sign they might have. So are they consistent with your hypotheses? And you're going to tell me what those beta coefficients say, and that's where the margins come in handy. Since you've already done this in regression, doing it in Logit is not that much different. All right, we're going to wrap it up there. And obviously, as always, if you have questions, let me know. Happy to work through this with you.